Hi everyone, I'm Tim Kington and this is Coding is for the Birds. Daisy and I are working our way through Advent of Code 2021 and this is day 9. Okay, so for this problem, we're trying to model smoke flow through some caves. We have a height map of the floor of the caves and smoke flows to the lowest point. And so what we're trying to do is find the low points. So locations that are lower than any of the adjacent cells. I'm not sure what we're supposed to do if there are two next to each other that are equal, like if this was 5, 5. But it does say lower than all of the adjacent cells, so I guess we'll try it that way. We need to find the low points. The risk level of a low point is 1 plus its height, and we want the sum of the risk levels. Okay, so we want to create a grid of our numbers, but we don't know how many lines there are going to be yet. So I guess we'll read our input into a list. And then we'll just add it here. Okay, now we can create a grid. And our x will be the length of a line. So we'll say lines.get0.length. And the number of lines here, so lines.size. I guess this doesn't work. We need an index, don't we? It's the char, so line.char at x minus 0. Okay, now we have our grid. Now we can iterate through it. And now we need to check all the neighbors. So we should probably have a list of offsets that give us the neighbors. So we'll have -1, 0. We'll have 0, -1. We'll have 0, 1. And we'll have 1, 0. Those should be our 4 neighbors. And we'll say nx is x plus offset sub 0, and y is y plus offset sub 1. And then we'll say if nx is less than 0, or nx is greater than grid.length, or ny is less than 0, or ny is greater than grid sub x.length, then we're not going to process this point because we went off the edge. Okay, now we're going to need to check to see if any of the neighbors are less than or equal to this cell. So we're going to say Boolean low point is true. And then here we're going to say if grid sub nx and y is less than or equal to grid xy, then it's not a low point. The low point equals false and break. And so if we get down here, if low point, we're going to add to our total. So total plus equals, what was the danger level? It was It's 1 plus its height. So we're going to add on grid sub xy plus 1. And then down here we'll print our total. Okay, so let's try running that. All right, line 36 went out of bounds. Oh, this should be greater than or equal. Okay, 528 was our answer. Might be right. Seemed pretty simple. All right. Okay, so now we need to worry about basins. A basin is all of the locations that flow downward to a single low point. Locations of height 9 do not count as being in a basin. All other locations will always be part of exactly one basin. The size is the number of locations within the basin. Okay, so here these all flow down to this 1. This whole area flows down to the 0. This area flows down to this 5. Okay, so we need to find the basins. And we need to know what their size is. Okay, so I think what we're going to do is pick a cell and then find all the cells we can reach from there. And that'll be the size of a basin. Yeah. Okay, so what we really need to keep track of here is cells that have already been visited. So I think we can create a Boolean array. And it'll be grids dot length and grid sub 0 dot length. And those will all be false. And now we're going to go through our grid. And so here we'll say if grid xy is equal to 9, or grid or visited xy, then we're going to skip this one. And otherwise, we're going to add it to our queue. So we're going to have a queue of int array. Can I even do that? I don't think I can do that. Great. Okay, so we're going to have a queue of point. New linked list. And then we're going to put our point in it. So we'll say points.add new point. I wonder what point this is using. AWT point, that's probably okay. Of xy. And then we're going to have a loop while points is not empty. So while not points that is empty, we're going to keep removing points, counting them, adding them. So I guess here we're going to say our basin size is 0. So we're basically going to do a breadth first search here. So we'll say point is points.pull, and then we're going to count it. So basin size plus plus, and then we're going to look at its neighbors. So we're going to do something very much like this. And then for each neighbor, we're just going to say if it's not a 9, right? I think we can just say that. The question is if we can have like a ridge. So there's a ridge of height 6 in between two basins that are lower than 6. But the description of the problem, I think, is unclear about how to count that. So this is probably okay. As long as it's not a 9, then it's part of our basin. So we're going to say points.add new point and x and y. And we don't need to break out of the loop. So we're going to add neighbors. We keep processing points until we're done here. And this is going to be, this is point.x, and this is point.y. And here, I guess this is, we'll just say grid 0.length. That's fine. It's a rectangular grid. So this should find the size of our basin. Low point we don't care about anymore. And then for scoring, we had to multiply together the size of the 3 largest basins. Well, that's kind of obnoxious. Okay. I guess we'll add the basins to a data structure. So we're going to have a tree set of amateur sizes. And then here we figured out the basin size. So we'll say sizes.add basin size. And then down here I should be able to do something like descending iterator. I guess that's fine. And then we're just going to say score is 1, and then we'll say score times equals that next. And we'll do that 3 times, right? And we'll print it. All right, let's see what happens. It would be surprising if this worked on the first try. Looks like an infinite loop. Yeah, I forgot to mark things as visited. So when we remove a point, we need to mark it as visited. And then here, we need to check visited too, so we shouldn't go back to if not visited, x and y, and it's not a 9. Now it should at least terminate, I hope. Well, that's a big number. Maybe we need a long to hold this. Or maybe it's broken. Let's see what happens. That is too high. Okay. Let's try this input and see if we get the right answer. All right, 5148 is not right. We should have 4 basins, it looks like. So let's see what we have in our list here. Sizes are, the first one's right. Oh, I think I know what happened. Did basin size not get reinitialized? No, this seems okay. All right, let's walk through this and see what happens. So our point 0, 0 makes sense. Now we're at 0, 1. Then we're at 1, 0, and then we're done. Okay, so that's that little upper left corner. We handled that. That's fine. All right, I was just looking at the wrong thing. So 0, 3, 1, 3, 1, 2, 1, 4, 2, 3, 2, 2, 2, 2 again. Yes, we're marking this as visited at the wrong place. We need to mark it as visited when we add it. Okay, so this needs to be an x and y. this first point needs to be marked also. And we should probably call this seen, not visited. This isn't really our visited. Okay, I bet that's going to be better. Well, now it's 378. Okay, that's too low. So what did we come up with for sizes? 3, 9, and 14 is okay. But there are 2 9s. Yeah, I just made a dumb mistake here. Okay. So this can't be a tree set. It needs to be like a... Is there a nice thing that'll sort these for me? I guess not, huh? We'll just make it an array list. I guess? Yeah, that's fine. It's a list of integer. New array list. We add the sizes. Here we're going to go sort it. So we'll say collections.sort sizes. And then we're going to get an iterator, list iterator at the end, which is at sizes.size. And then we're going to call previous here. What's wrong with that? Oh, this has to be a list iterator. Okay, now we'll probably get the right sizes. So here, 39914, good deal. Yeah, 1134 is our answer, which is correct. So let's go back to the real input and see what we get. Okay, that's a more reasonable number probably. All right. All right, well, that wasn't too bad. Mostly I had some bugs there while I was working on the breadth first search. What could we do differently? I think we're probably going to have a bunch of problems based on grids. And so maybe we should take some of this code that I wrote to find neighbors and refactor that to be a little more general so we can reuse it in other days. It also might be nice to have a breadth first search method that we can just call. So we'll see. If we run into that again, maybe it'll be worth the trouble of rearranging that code. Daisy is ready to go here. Thanks for watching. Don't forget to like and subscribe.